The blade of a windshield wiper sweeps out a 135-degree angle in one cycle. The base of the blade is 12 inches away from the pivot point, and the tip of the blade is 32 inches away from the same pivot point. What area does the wiper cover in one cycle, round to the nearest square inch? Well, so I've drawn a rectangle here that's all colored in blue, and I'm imagining a very small windshield wiper down here. Hopefully, if your windshield's this big, you get a larger windshield wiper. But I want to imagine what happens as that windshield wiper turns through a 135-degree angle, so until we get to about here. And I think we can imagine that the tip of the windshield wiper here will make a little arc as it sweeps through. But the bottom of where the windshield wiper is, right? If you think about your windshield wiper, it attaches to the car. There's an arm, and then the part where the wiper actually drags across the windshield. And that bottom part of the wiper would also make a semicircular arc. So if I think about the amount of windshield that gets cleaned as the wiper goes across, well, it would look something like this. Right, that's the part the windshield wiper actually clears off. Hopefully your windshield wiper does a little bit better than that. So I'm actually being asked to find that area, an area of a shape that looks like that. So let's see if we can have a picture maybe with a little more detail to it, or at least more helpful. So I have a windshield wiper attached to a pivot point. The wiper blade would end at the top of it, but I'm told that the base of the blade, the wiper itself, is 12 inches from the pivot point, so that's 12 inches. And that tip all the way out there is 32 inches away from that same pivot point. All right, so 32 inches. Well, that would tell me that this windshield wiper blade itself is only 20 inches long, and I may need to know that, maybe I don't, but that's the part that actually gets cleared. So I imagine rotating my windshield wiper through that 135-degree angle, not to scale, but maybe about like that. And I get these two semicircular arcs, or circular arcs, which I'm doing a very bad job of drawing. Pretend that's part of a circle, pretend this is part of a circle. And then we're supposed to find this area. Well, I'm hoping that you're being a creative problem solver right now, and I'd like you to pause the video and see if you can think of an approach to calculate that area based on what we've talked about in class, and then I'll talk you through it. All right, well, when I look at this, I see a big circular sector, so I'm thinking I'm going to use the area of a circular sector formula, that the area of a circular sector, the whole circular sector, would be 1/2 r squared times theta, where that angle is measured in radians. When we derive this formula, we use an angle in radians, so that only takes angles in radians. And so what I can do is I could actually find the area of this whole circular sector, including this part down here, right? So the red and the purple all together. All right, well, I think I know how to do that. Right, the area of the whole thing would be 1/2, the radius is 32 inches, well, I don't need to say inches there, but 32 inches squared, times the angle in radians. Well, I'm told that this is a 135-degree angle, so I need to convert that to radians. Fortunately, I know that's 3 pi over 4, and so I'm ready to find this larger area. So let's see. What I'm going to do is leave this in terms of pi right now. So I have 1/2 times 32 squared. I'm just going to say times 3/4 because I'm going to leave the pi on there. So that would be 384 pi square inches. Well, that's clearly not the answer to my problem. That's too much area, right? That's the area of the whole circular sector. But now what I'm going to do is I'm going to find the area of just the little purple circular region. So this is the whole thing, right? The red and the purple. And now what I want to do is just find the little purple area. So that little radius is only 12 inches. So 12 inches squared times the same angle. All right, so 1/2 times 12 squared is 144. So let's see, 1/2 times 144 times that 3/4, that'd be 54 pi. So now I know the whole area and the little area, and to find the area I'm looking for, I really just need to subtract them. 384 minus 54 is 330 pi. Square inches, and here at the end I'm asked to round to the nearest square inch, so I'll multiply 330 by pi and find out that that is about 1036.7 square inches. And now we found that annular regions area, right? It looks like part of a washer.